Hey guys, so this is part 2 of finding the solutions of a quadratic review. In our first video, we reminded ourselves that whenever we're asked to find the solutions of a quadratic, we could be asked to find solutions, or they could use the term zero or even root. So solutions, zeros, roots are all the same whenever we are being asked to solve a quadratic. And in that first video, we reviewed solving a quadratic by using the quadratic formula. In this video, I want to talk about completing the square, because what's nice about with completing the square is there's not this formula that we're trying to memorize, right? We're trying to create a perfect square trinomial, and then we're able to take the square root to solve instead. So let's go ahead and jump right in, refresh our memory on this process. So we'll have example 1. In example 1, we have x squared plus 6x minus 3 is equal to 0. And our first step here is we really need to get these terms with x on one side together so we can focus on those. And so I'm going to add this 3 to the other side. So we have x squared plus 6x equals 3. And now what I want to do is I want to create that perfect square trinomial with the x squared plus 6x. And the way we do that is we think of standard form being ax squared plus bx plus c, and I'm trying to find that c that makes a perfect square trinomial. And so the way we can do that is by taking b divided by 2 and squaring it. As long as a is already 1, that's another thing we'll see in our second example. We have to have a be 1, which it is in this case, and we can take the b term, divide it by 2, and square it. So in this case, we're going to have 6 divided by 2 squared. So 3 squared is 9. And what this helps us figure out is the c value to add that creates that perfect square trinomial. So we have x squared plus 6x plus 9. And the thing is we have just added this 9 into the equation. We cannot change the value of this equation. So what we do to one side of the equal sign, we have to do to the other. So I have to add this 9 on the other side as well. And looking at this, like I said, x squared plus 6x plus 9 is a perfect square trinomial, meaning it becomes a binomial squared. There are a few little tricks that we can use to remember what goes in there. First of all, if you factored it, it would have been, what are the factors of 9 that add to give me 6? It would be 3. But every single time, it's going to be b divided by 2, which is that 3 value. So we're going to have x plus 3 as my binomial that is being squared. X plus 3 squared. And it equals 12. At this point, I have the binomial being squared. So to get x, we're trying to get x to be just this linear equation. I can take the square root, because the squared and the squared cancel out. We get x plus 3 equal to plus or minus the square root of 12. When we bring that square root in, we have to think of plus or minus, both cases. And here, we need to try and simplify the radical. So let's go ahead and do that. If we have 12, here I'll come to this side and we'll write our final answer there. If we have the square root of 12, 12 is not a perfect square, so I want to think of the largest perfect square that goes into 12, and that's going to be 4. So we're going to have the square root of 4, and that's going to be left with 3. So we've split up that radical to the square root of 4 and square root of 3, which is just 2 square root of 3. So that's what I'm actually going to replace with the square root of 12. So 2 square root of 3. So let's rewrite this so we have it here. X plus 3 equals plus or minus 2 root 3. Now all we have to do is we're trying to get x by itself is just subtract this 3 to the other side. So x is equal to negative 3 plus or minus 2 square root of 3. This answer here, it's our solutions, our zeros, or our roots. So let's see another example of this. In this next example, this one worked out nice. No fractions, anything like that. But let's see what happens when we do end up with some fractions. All right, so with example 2, we have 4x squared plus 10x minus 3. Okay, and let's go ahead and set it equal to 0. If you were to just be given an expression, set it equal to 0, and it's the same process. You're trying to find those solutions of a quadratic, meaning you're thinking about that quadratic being set equal to 0. Okay, so we want to get the terms with x on this left side together. So we're going to have 4x squared plus 10x equals positive 3. Now at this point, whenever we are completing the square, we want to go ahead and have a be 1. So whatever the a term is, we want to divide everything by that value. Here a is 4. So I want to divide everything by 4. This gives me x squared. Simplify this fraction and it will be 5 halves x equals 3 over 4. Okay, and at this point, we can do that process of taking b, divide it by 2, and square it to know what that c term would be to make a perfect square trinomial. I know this looks a little different than what we saw, but it is still possible to do. So what we want to do, like I said, b is 5 halves, divide that by 2. We want to square that. Okay, don't let this mess us up. Think about this as 2 over 1. We are dividing two fractions. Remember, we think of that as multiplying by the reciprocal, so like multiplying by 1/2 and squaring. And so this is actually like squaring 5 over 4. Remember the rules of squaring a fraction? We square the top, we square that numerator, and we square that denominator. So we end up with 25 over 16. This is the fraction that I need to add to both sides of the equation to create a perfect square trinomial on the left. So we have x squared plus 5 halves x plus 25 over 16 equals 3 over 4 plus 25 sixteenths. Now we can create our binomial being squared, which is the whole point of finding that perfect square trinomial. Remember, it's whatever b divided by 2 was. What value did I square? I squared 5 over 4, positive 5 over 4. So this binomial is x plus 5 over 4. We have that being squared, and it's going to equal 3 over 4 plus 25 over 16. So obviously here we need to get a common denominator. Let me go ahead and do that here. The common denominator is going to be 16. That means I need to multiply the top and bottom by 4. So we have 12 over 16 plus 25 over 16. And that is going to give us 37 over 16. So how about we go ahead and just write this out together. So we've got x plus 5 over 4 squared equals 37 over 16. At this point we have that binomial being squared. We know what it equals. Take the square root, giving us just a linear equation to solve. That's x plus 5 over 4. Now here we do need to remember some more properties of radicals. When we have a fraction, we can split up the radical. It's like taking the square root of the 37 and taking the square root of 16. And don't forget that plus or minus. When we bring that square root in, we've got to put plus or minus. So we cannot simplify the square root of 37 at all. There's not a perfect square that goes into that. But luckily, it's square root of 16. That is a perfect square, and so we have just 4. So x plus 5 over 4 is equal to plus or minus the square root of 37 all over 4. Our last step here, get x by itself. Subtract that 5 over 4. So x is equal to negative 5 over 4 plus or minus the square root of 37 over 4. The only other thing you could do is combine these two fractions. They already have that same denominator. So you could see written either way. Negative 5 plus or minus the square root of 37. We cannot combine those any further. Equals 4. Here are our solutions, zeros, roots, whatever term is used. All right, so let's have you try one. I'm going to give y'all a few seconds to start on that before I get going on it as well. But your problem here is going to be x squared minus 2x minus 5 equals 0. Solve this quadratic, find its roots by completing the square. Alright, so here so far I've started off by moving the 5 to the other side of the equation and try to figure out what value I could add to the end of this binomial here to create that perfect square trinomial, taking b divided by 2 and squaring it, which gave us this 1 here, telling me what I needed to add to both sides of my equation. Now, at this point we might get stuck. What am I trying to do? Well, what did we just create? A perfect square trinomial, meaning it can be factored into this binomial being squared. And remember that little hint I gave you. Whatever you square, whatever b divided by 2 is, that is always what goes here. X minus 1. X minus 1 being squared. And you could always go back to factoring. What multiplies to give me positive 1? Adds to give me negative 2. In both cases, it is that negative 1. And it equals 6. Now, take the square root. We want to get x by itself. So our next step there, take the square root. X minus 1 is equal to plus or minus the square root of 6. This square root cannot be simplified at all. We leave it just as it is. So our final step is to simply add 1 to both sides. So x is equal to 1 plus or minus the square root of 6. And these are our solutions, zeros, or roots of this quadratic.